Video, we are going to look at the derivative of the inverse of f of x at the value of 3. Alright, so one of the things we need to do is we need to figure out if this even has an inverse function, at least for these x values. So this is just a rational function, and I could go through all the rational rules, I guess, and make a graph, and that would be a little time consuming. But at some point we're going to need the derivative anyway, and with the derivative that can help us see that this is in fact one-to-one if we're using this restricted domain. So to find the derivative of this looks like it's wanting us to use the quotient rule, since we've got something divided by something. And the quotient rule says take the derivative of the numerator, multiply it by the denominator, subtract the derivative of the denominator times the numerator, and put all of that over the denominator squared. Alright, so if I simplify this would just be an x minus 2. This would be a minus x plus 6, which would be like a minus x and a minus 6. So those cancel out and go to 0, and we get negative 8 over x minus 2 squared. Alright, so if we're only looking at these x values, where x is bigger than 2, then this derivative is negative. It would always be negative, because if x is bigger than 2, then this is always going to be positive, and then you square that, that's always going to be positive, but then you've got a negative divided by something that's always positive, so this is always going to be negative. So if the derivative is always negative, we know that this thing is going to be decreasing all the time for these x values. So if I don't know what the graph looks like, but if it's going down all the time, then it does pass the vertical and horizontal line test. So it is one-to-one. Therefore, this function does have an inverse function. Alright, so now that we know that exists, we can figure out what is the derivative of the inverse of this function at this value. Alright, and we need to have memorized here is if we want to know the derivative of an inverse function, derivative of an inverse function, that is going to be 1 over the derivative of that function times the inverse, or not times the inverse, but with the inverse function of x plugged into that. So very small differences in notation here, but very big difference. So this part of it's going to be derivative, this part is going to be inverse. Alright, so for us, in this particular question, we are trying to find the derivative of the inverse when x is 3. So we will do that by doing 1 over the derivative of the inverse when x is 3. Okay, so we need to evaluate this, so this should give us a number, and then we can plug that number into the derivative, which we have already found the derivative, and since it's 1 over that, then we can just take the reciprocal to get our final answer for this question. But you may ask yourself right here, how am I supposed to know what the inverse of f at 3 is? Because we know the f of x equals, we know what the derivative of f equals, but we don't have the inverse function. Sometimes you can just go ahead and switch x and y's and solve for y, and I guess you can go that route, but that wouldn't really help you here, because if you switch x and y, you're going to have y's in 2 spots, and it looks like it might be kind of difficult to solve. So instead, a better strategy is to think about how a function and its inverse are going to relate to each other. So I'm trying to figure out on the inverse function when x is 3, but you have to understand that if inverse just means you're switching x and y, the point that correlates when x is 3 on the inverse is the same as the point that correlates to f of x when 3 is y, because you're just switching x and y. So if I can ask myself, well, when does this equal 3, or when is y equal 3, for what x value? If I can solve this, then I know this, and if I know this, then I'm going to know that, and that's going to be this. And that's kind of the last big secret here before everything else will fall into place. So I can multiply both sides by x minus 2 and distribute, and subtract an x from both sides and add a 6 to both sides and divide both sides by 2. And it looks like on the function when y is 3, x is 6, which means on the inverse function when x is 3, y is 6. So on the inverse function, when x is 3, y would be 6. Okay, so now I need to plug 6 in to the derivative function, but I've already found the derivative up here, so that shouldn't be too big of a deal. It's -8 over 6 minus 2 squared, which would be 4 squared, which would be 16. So this would be 1 over -1/2. And dividing by -1/2 is the same thing as multiplying by -2. Or if you'd rather think of this fraction sign as a division sign and change it to multiplying by reciprocals. And finally we come out to our answer of -2.